All right, let's get straight into it. Welcome to today's explainer, where we're going to completely demystify API authentication. Look, for a lot of developers, dealing with authentication feels a bit like dark magic. You send a request, something fails, and you're just left staring at an error code with no obvious way forward. But here's the secret. Authentication is not magic. It's literally just HTTP headers. And by the end of this explainer, you're going to master them and debug these errors exactly like a senior engineer.
We've absolutely all been there. The API is returning a 401, but I just don't know why. It's arguably the single most common developer support complaint across the entire industry. You know the feeling, right? You're trying to integrate a new service, you've carefully copied the code from the documentation, but instead of that glorious 200 OK, you just hit a wall. It is incredibly frustrating. But today, we're setting up the ultimate playbook to permanently solve this issue for you.
So, let's clear up the biggest point of confusion right off the bat, the actual difference between a 401 and a 403 status code. Knowing this literally cuts your debugging time in half. A 401 unauthorized actually means you are unauthenticated. Think of it like you're knocking on a locked door without a valid key. The server is basically saying, I have absolutely no idea who you are. On the flip side, a 403 forbidden means you are authenticated but you lack authorization, meaning you actually have the key to the building. The server knows exactly who you are, but you're trying to sneak into a restricted room you just don't have permission to be in. If you remember that 401 means who are you and 403 means you can't do that, you are already way ahead of the game.
Here's our roadmap for this explainer. We're going to cover the 4 common auth types, decode some JWT tokens live, look at the OAuth 2.0 client credentials flow, walk through a step-by-step debugging guide, and wrap up with a real-world support scenario.
Okay, starting with Section 1, the 4 common auth types you need to know.
Out in the wild, you're primarily going to encounter 4 main mechanisms: API keys, basic authentication, bearer tokens, and OAuth 2.0. If you use a tool like Postman, you'll actually see these exact 4 options neatly organized right there in their Auth tab. An API key is usually just a simple string sent in a header or query parameter. Basic Auth sends a username and password that are encoded in base 64. Bearer tokens use a cryptic string, which is very often a JWT, to grant access. And OAuth 2.0 is really the broader framework that issues those tokens in the first place.
And here's the crucial point to remember from my earlier mantra. Authentication is just headers. If you pop open your Chrome DevTools Network tab, this is exactly what you should be looking for. For basic auth, it's authorization basic followed by your encoded credentials. For bearer tokens, it's authorization bearer followed by the token. And listen, here is a massive trap that catches so many developers. That bearer prefix, according to the RFC specification, it is strictly case sensitive. It has to be a capital B followed by exactly 1 single space. Just a tiny typo there will throw a 401 error every single time, even if your token is perfectly valid.
Moving right along to Section 2, decoding JWT tokens live.
So, what is a JWT? It's a stateless, base 64 URL encoded token used to securely transmit information. But pay very close attention to this next part. It is encoded, not encrypted. This is such a huge misconception because it's only base 64 URL encoded. Absolutely anyone who intercepts that token can decode it and read the payload inside. The security of a JWT doesn't come from hiding the data. It actually comes from a cryptographic signature that proves the token hasn't been tampered with since the server issued it.
A JWT is basically made up of 3 distinct parts, separated by little periods. First up is the header, which tells you the token type and the signing algorithm used, like HS256 or RSA. Second is the payload, which contains the claims, and claims are just the actual facts about the user or the service, like their user ID or email. Finally, the signature is the cryptographic hash. If you take a token right now and paste it into a free tool like jwt.io, it'll instantly decode the header and the payload for you to read in plain text. You only ever need the server's secret key if you want to verify that signature.
Now, when you decode that payload, you're going to see a claim called XP. That stands for expiration. The value you see there, like this long number here, is a Unix timestamp. It just represents seconds since the epoch. Why does this matter to us? Because an expired token is hands down the single most common cause of a 401 unauthorized error in modern web apps. If your token's XP time is in the past, the server is going to reject it no matter how perfectly formatted your headers are.
All right, Section 3, the Auth 2.0 client credentials flow.
So OAuth 2.0 has several grant types, but the client credentials flow is the absolute standard for server-to-server or machine-to-machine communication, where there's no human user sitting at a keyboard typing in a password. Here's how it plays out. Step 1. Your backend service sends its client ID and client secret over to the authorization server. Step 2. The server validates those credentials and shoots back a short-lived access token, which is usually a JWT. Step 3, you take that token and attach it to your authorization header as a bearer token to call the protected API. And what's awesome is that you can easily simulate this exact flow yourself. Just use Postman's free tier, pop your ID and secret into the Auth tab, get your token, and test it against a free endpoint like http://bin.org/bearer to see a live 200 OK for yourself.
Which brings us to Section 4, our step-by-step debugging guide.
Whenever you face an authentication error, seriously, do not guess. Just follow these 3 steps. Step 1. Check the HTTP header. Open up your DevTools Network tab. Is the authorization header actually there? Is it formatted perfectly, with exactly bearer and a single space? Step 2. Check if the token itself is valid. Copy it, paste it into jwt.io, and look right at that exp claim. Has it expired? Step 3. If you're getting a 403 forbidden instead of a 401, check the token's scope. The payload will often list exactly what actions the token is allowed to perform. If your token only has read access, but you're trying to post or delete data, the server is going to hit you with a 403 because you lack the correct permissions. A great tip is to use Postman to build the request on one monitor and DevTools on the other to inspect what actually goes over the wire.
Let's put this all into practice with Section 5, a real-world support scenario. Imagine a client's integration is returning 401 errors, but only intermittently. Everything seems totally fine, and then boom, it fails. Well, a senior engineer doesn't panic, they intercept. Step 1, they use a tool like Charles Proxy to capture the actual outgoing request from the client app. They inspect that authorization header and grab the token. Step 2, they paste that bearer token right into jwt.io to read the claims live. Step 3, the big discovery. They check the X claim and compare it to the token's IAT, which is the issued at time. They realize the token is only valid for 1 hour, but the client app is trying to cache and reuse that token for 2 hours. As the old saying goes, there are really only 2 hard things in computer science: cache invalidation and naming things. For the first hour, everything works beautifully. For the second hour, literally every request hits a 401 because the token is dead. The engineer documents the fix, telling the client's dev team to update their cache logic to refresh at, say, 55 minutes, and sends it back. Mystery solved. Systematically.
And that wraps up our explainer. The very next time you face a 401 or a 403 error, don't guess and please don't panic. Just open up your network tab, decode.token, and ask yourself, what secrets is the authorization header revealing? You've got the playbook now. Go master your headers. Keep building, and we'll see you next time.